Hello everybody. In this video we are going to be looking at the solutions to the college prep waves and vibrations homework problems 11 through 15. Let's start with problem 11. The Willis Tower in Chicago. I have a lovely picture of it right there. It used to be called the Sears Tower, but they call it the Willis Tower now because Sears is bankrupt. Let's see, it sways back and forth in the wind with a frequency of about 0.12 hertz. Been to the top of that sucker, by the way. It's pretty cool. What is the period of its vibration? So the frequency of the vibrations is 0.12 hertz, and we are being asked to find the period. So I know that the period is simply the reciprocal of the frequency. Remember, period and frequency are reciprocals of one another. So if I have the frequency and I want to find the period, I just take 1 and divide it by the frequency. If I had the period and I wanted to find the frequency, I would just do 1 divided by the period. But here we have the frequency and we are looking for the period. So 1 divided by the frequency, or 1 divided by 0.12 hertz, is going to give me a period of 8.3 seconds. Problem 12. An ocean wave has a length of 12.0 meters. A wave passes a fixed location every 3.0 seconds. What is the speed of the wave? So we are given the wavelength, or the length of the wave. The length from crest to crest is 12 meters. And remember, we use the Greek letter lambda to represent wavelength. So my wavelength is 12.0 meters. I am given the period, which is 3.0 seconds. And if you're confused as to what is the period, what is the wavelength, always go back to your units. Look at your units. My unit here is seconds. So I know because my unit is seconds, that has to be my period. And it's only one cycle. So remember, the period is seconds per cycle. So one wave or one cycle passes a location every 3 seconds. So my period is 3 seconds. If I were dealing with frequency, we'd have the hertz as my unit, but because it's seconds, I know it's period. And we are looking for the speed of the wave. So I know that the speed of the wave is equal to the frequency times the wavelength. And I know the frequency is the reciprocal of the period, so I can just replace my frequency here with 1 divided by t, same thing. And that's effectively going to have 12 meters divided by 3 seconds is going to give me 4.0 meters per second. Problem 13. Water waves in a shallow dish are 6.0 centimeters long. At one point, the water moves up and down at a rate of 4.8 oscillations per second. So I know that my wavelength is 6 centimeters. I do need to convert that to meters, so that is going to be 0.060 meters. And I know I am given the frequency is 4.8 hertz. Now, the unit we're given for that 4.8 in the problem is oscillations per second. My time unit, seconds, is in the denominator of my unit, right? There's my division sign right here. That's in the denominator. So because I have seconds in the denominator, I know I'm dealing with frequency, and my unit is hertz. The first thing that they want us to find out is the speed of the wave. So what is the wave speed? I know wave speed is equal to the frequency times the wavelength. So 4.8 hertz times 0.060 meters will give me a wave speed of 0.29 meters per second. The second thing that they are asking us to find is the period of the wave. So we want to find the period. And I know the period is simply the reciprocal of the frequency. So 1 divided by my frequency, or 1 divided by 4.8 hertz, will give me a period of 0.21 seconds. Problem 14. Water waves in a lake travel 3.4 meters in 1.8 seconds. The period of oscillation is 1.1 second. So we are given a bunch of stuff here, and we're given 2 different time values, and let's straighten those out so we don't get confused. We know that the total distance that the wave travels is 3.4 meters. It travels at 3.4 meters in 1.8 seconds. So that's just how long does it take for the wave to travel a distance of 3.4 meters. It tells me the period of oscillation is 1.1 seconds. So that's my period. My period is 1.1 second. 1.8 seconds is simply the time it takes for that wave to travel a distance of 3.4 meters. The first thing they want us to find out in this problem is what is the speed of the water wave. So we are looking for the velocity of the wave. And I know that I can find the velocity from the distance it travels and the time it takes to travel that distance. That is our velocity formula from way back when. And remember, I said in the PowerPoint narration that our wave speed formula is really a derivation of our formula of velocity equals distance divided by time. And that's the one that we want to use here just to find the speed of the wave. So I know that the distance the wave travels is 3.4 meters. The time it takes to travel that 3.4 meters is 1.8 seconds. So 3.4 divided by 1.8 will give me a wave speed of 1.9 meters per second. The next thing I want us to find is the wavelength. So we are looking for lambda. And I know my wave speed formula is the speed of the wave equals the frequency times the wavelength. If I want to solve that for wavelength, I know wavelength is equal to velocity divided by frequency. But because frequency is equal to the inverse of the period, I can replace the frequency with the period. So the wavelength is going to equal the velocity times the period of the wave. So 1.9 meters per second times 1.1 meters per second will give me a wavelength of 2.1 meters. Problem 15. A sonar signal of frequency 1.00 times 10 to the 6th hertz has a wavelength of 1.50 millimeters in water. So I am given the frequency of 1.00 times 10 to the 6th hertz. I am given the wavelength of 1.50 millimeters, and I know I need to convert from millimeters to meters. So converting that to meters will give me 1.50 times 10 to the minus third meters. The first thing I want us to find in this problem is what is the speed of the signal in water. So we are looking for the wave speed. I know the wave speed is equal to the frequency times the wavelength, and I'm given both of those values, so I just simply multiply them together. 1.00 times 10 to the 6th hertz times 1.50 times 10 to the minus third meters is going to give me a wave speed of 1.50 times 10 to the third meters per second. The second thing they want us to find is what is the period in the water. And I know that I'm looking for the period. So the period is simply the reciprocal of the frequency. So 1 divided by 1.00 times 10 to the 6th hertz is going to give me a period of 1.00 times 10 to the minus 6th seconds.